So most of you get to that point okay. And you say, all right, and so we have to set that equal to 5 over 12. Well, that looks like x is negative 5 and y is 12, and you move on. But the problem is 5 comma 12 is not on the circle. So what do we have to do? It has to satisfy this equation, but it also has to satisfy this equation up here. We have, think of it going back to algebra. We have two equations. We have two unknowns in those two equations. So what I would recommend doing is take the derivative equation and let's solve it for x or y. I'm going to solve for y. So I cross multiply, get negative 12x equals 5y. So that means y equals negative 12x over 5. Now I'm going to plug that back into my original equation. Okay? I'm going to put it in place of x, so in place of y. So we get x squared plus negative 12y over 5 squared equals 1. Negative 12x over 5 squared equals 1. Now I've got an equation with just one variable in it. Now it should be easier. Common mistake for students to make once they get to this point here. Ooh, I don't like all those squares, but everything's squared, so a lot of students will decide, all right, that means I can say x plus 12x over 5 equals 1, because the square root of x squared is x, the square root of that is that, the square root of 1 is 1. Makes my life easier. Wrong. Can't do that. Give you an explanation. If we've got 3 squared plus 4 squared, 3 squared is 9, 4 squared is 16, the square root of that is 5. But if we just take the square root of 3, the square root of 4, 4, add them together, we don't get 5. So you can't take the individual square roots. We have to go through this kind of a long, arduous way here. So I would go with this, x squared plus 144x squared over 25 equals 1. Personally, I don't like fractions, so I'm going to multiply everything by 25. I'm going to get 25x squared plus 144x squared equals 25. That's just multiplying everybody by 25. 25 and 144 is 169. X squared equals 25. All right. So x squared equals 25 over 169. Now, I can take the square root because I don't have any plus signs in there anymore. I can take the square root of each side. So if I take the square root of x, I get plus or minus 5 over 13. Now, why do I get to say plus and minus? How do I know it's not just plus? It's x squared, yes. We are introducing a square root. We are taking the initiative to take a square root, so it's 2 of them. Also, x squared implies that we've got 2 answers. So, plus and minus 5/13. Well, so how do we get our answers up there? Well, let's see. That's our x's. We need y's. We've got an equation right here that says y equals negative 12x over 5. Oh, my goodness. So y equals negative 12 times 5/13 divided by 5, right? Oh, my goodness. That looks terrible, doesn't it? Well, what does that work out to be? Negative 12 times 5 over 13, keep change flip, times 1 over 5. How about that? So I get negative 12/13. So when I put positive 5/13 in there, I get negative 12/13 out. What happens when I put negative 5/13 in there? If we were to change this, if instead of a 5/13 that had been negative, that would change that to negative. That would just simply make our answer positive. So there are our two answers that we got. 5/13, negative 12/13, and negative 5/13, 12/13. Well, which one do you put where? Go back and read the instructions. The positive y coordinate goes in the first one. So be sure to put the negative 5/13, positive 12/13 in there. The negative y coordinate goes in the second one. So be sure you put the 5/13, comma, negative 12/13. Does that help to understand that problem now, people? Okay? All right. Any others on the web assignment that you've looked at and said, hey, I don't know what to do yet? I'm a little bit concerned because you're going to have time to look at problems in a moment.
Real quick, can you just go back down?
I certainly can.
I just want to say, okay, so you just plug X into the second.
That's right. I had the equation y equals negative 12x over 5 because that's what I put right there. I could have just as easily put it into the x squared plus y squared equals 1 if I'd chosen to do that. But this gives you a couple of answers out of there. All right? Is that clear?
Can you explain how to do the number 9?
All right. Let's see. Number 9. Come on. Just make it bigger, Ely. Come on. All right, let's get a picture of that so I can write on it over here. Using a graphing utility to sketch the. Come on. Maybe that's that. Use a graphing utility to sketch the intersecting graphs of the equations and determine whether or not the equations are orthogonal. Hard word to say this early in the morning. Two graphs are orthogonal if at their points of intersection the tangent lines are perpendicular to each other. Okay, so you said you got the graph okay? All right, now, so look at this thing. It says they're orthogonal if at their points of intersection the tangent lines are perpendicular. So what does tangent lines tell you to do? Derivative, okay? So if I take the derivative of the top one, I get 2x. No. If I take the derivative of the top one, I get 4x plus 2y, y prime equals 0. If I solve that out, I get y prime equals negative 2x over y. You with me there? You see how I got that? I did some math in my head. I moved the 4x over, divided by the 2y. If I take the derivative of the second one, I get 2y, y prime equals 9x. So that means it just equals 9. So y prime equals 9 over 2y. Okay, so we need to know when they are perpendicular. What does it mean to be perpendicular with the slopes? Right, so if one of the slopes is 3, the other slope's going to be negative 1/3 or whatever. So here's what I think you need to do. We need to figure out where these points of intersection are. How do we do that? How do we figure out where the points of intersection are? How do we figure out where two things cross? That's right. When are these two equations up here equal to each other is what we're saying. When are these two equations giving you the same answer? Right. So look, I can put 9x in place of y squared up there, and I can get 2x squared plus 9x equals 11. Right? Don't factor an x out and say x equals 11 and 2x plus 9 equals 0. I'll throw stuff at you, okay? Move the 11 over. So let's write up here where we got more white space. 2x squared plus 9x minus 11 equals 0. How are you going to solve that quadratic? You could use the quadratic formula. That's what most of us would resort to. If you remember from Algebra 1, y'all remember the box method for factoring. You could factor it by using the box method. Either way you come up with here, you're going to wind up with 2x plus 11 and x minus 1 for an answer. Plus 11 minus 2, yeah. So that means x equals negative 11 twelfths, and x equals 1. Well, when x is 1, so that's just my x-coordinate. I need to know the y-coordinate to go with that. So let's look at this bottom one down here. Well, first of all, look at our graphs. Do you think the negative 11 twelfths we need to worry about? Why not? Negative 11 twelfths is, when x is negative 11 twelfths, is somewhere over here, right? It's not even on the graph. So all we need to worry about is the x equals 1. That makes it easier for us. When x is 1, what does that mean? When we plug 1 in there, we get y squared equals 9x. So y squared equals 9. So that means y equals plus or minus 3. So if I put, so I've got 2 points of intersection, 1, 3, 1, negative 3. You buy that? So if I put 1, 3 in here, I get negative 2 over 3. And if I put 1, 3 in down here, I get 9 over 6, which is 3 halves. Are those orthogonal? Yes, they are. What happens when I put 1, negative 3 in there? If I put 1, negative 3 in there, I get still negative 2 over negative 3 now, though. And down here, I get 9 over negative 6. That's 2/3. That's negative 3 halves. Yes, they're orthogonal. A lot of work, but do you see the flow to that there? Okay. Any other questions about the Weber sign right now that you've looked at? All right. I know y'all are freaking out over the Weber sign right now. And I did all of that writing not on my smart notebook. That's a bummer. Okay. I know y'all are freaking out right now, but we really do need to talk about the last topic for today of finding derivatives. Come on. Okay. This is the last topic of how to find derivatives. This is 16, exponential functions. Okay? Now, we will continue to take derivatives the rest of the year. But what we will begin focusing on in second quarter is why we're taking derivatives. What can we do with these things now that we know how to take them and all? So, as we talk about this, we're going to be looking at how to take the derivative of exponential functions. There are 2 graphs up here on the board. I don't know if y'all realize this, but this graph right here in blue is the graph of y equals e to the x power, and this one is the graph of y equals the natural log of x. So that's just what those graphs look like. Y'all probably don't remember that from anywhere, but that's what they look like. They are inverses of one another. Inverse functions undo one another. So these functions are inverses of one another. They're inverses because if you were to draw a line, wow. I don't know why it's doing that up there. Wow. Okay, let's try that again. I really need a line, not dots all over the place. If I take a line here at y equals x, which that's obviously not, if I were to fold my paper along that line, those graphs would line up. That means that they are inverses of one another. It's important to know as you work through problems later on, because sometimes it's going to be easier to work with one or the other, and we'll need to be able to convert back and forth between them. But the derivative of each of the x is what you need to learn today. It's very simple. The derivative of e to the x is e to the x. What's the second derivative of e to the x? E to the x. What's the third derivative of e to the x? E to the x. Every derivative of e to the x is e to the x. Real easy to know, real easy to remember. But as we talked about with a natural log, that works provided the argument is just a lone x. If the argument were always just a lone x, it would not be very interesting. It wouldn't make it challenging in here. So very seldom is the argument going to be just a simple x up there. Now that's ridiculous. I can't tell you. All right, let's try that. I'm about ready to throw it out the door. All right, let's try it now. It will erase them. How about that? If it's not a lone x, just like with the natural log, if this is a function of x up there, it's going to be e to that function times the derivative of that function. So, not anything real hard to understand, not anything, just something you got to memorize there. So, let's look at that. The derivative of e to the 5x plus 7. Just like with the natural log, we never change the argument. We're never going to change the power. So it's going to be e to that same power times the derivative of that, which is 5. And I'll go ahead and write the 5 up front. So the derivative of that is 5e to the 5x plus 7. And we can do all the fun things that we've been doing with derivatives all along, okay? We can find out where it has horizontal tangent lines, vertical tangent lines, equal to something, all those fun things. So let's look at a couple of other examples, and then you're going to be free to go. E to the 7 over x power. Okay? You're going to start off, it's the same thing. E to the 7 over x times, what's the derivative of 7 over x? Well, it's 7, think of it as 7x to the negative 1. So we've got to bring the negative 1 down. So it's negative 7 x to the negative 2. So we would write it as negative 7 over x squared. So we could simplify that by saying it's negative 7 e to the 7x all over x squared. Okay? Does that make sense? Find the point where F has a horizontal tangent line. What does that mean? Horizontal tangent line. F prime equals 0. Okay, how are you going to talk to me about taking the derivative of this thing? Product rule. Please remember that, okay? Product rule. So first, derivative of second plus second derivative of first. X e to the x plus e to the x. So, Marlon said that's horizontal tangent lines where that equals 0. So, let's do this. X e to the x plus e to the x equals 0. Now, there are two ways to solve this. Tell me something what are y'all going to want to do to solve this? Factor. That's the best thing to do here. Here's what some students will want to do. They'll say, okay, I can move this over here like this, negative e to the x, and I can cancel out the e to the x on both sides, because I got one on both sides, don't I? So I can just get x equals negative 1 out of it. The problem with that is you will oftentimes throw away an answer when you do that. So don't do this. I don't want to go into the mathematical reasons why you throw away an answer, but that's a bad habit to get into. I've seen a couple of you do that before where you've got 2x squared minus x equals 0. Well, I can say 2x squared equals x, I can throw an x away on each side, so I get 2x equals 1, x equals a half. You got it half right, because there should be two answers there. There should be two answers because it's x squared. I threw one away when I divided by x right here. So I don't recommend that you do that. I recommend that you factor. So if we're going to factor over here, tell me what we're going to factor out. E to the x. So we get e to the x plus 1 equals 0. So now what do? They're both equal to 0. Thank you. E to the x equals 0. X plus 1 equals 0. Well, I bet we know what the answer for this one over here. X equals negative 1. What about e to the x equals 0? That's right. We can't use a calculator. We've got to be able to either remember this because we remember the properties that Mr. Ely showed us on Monday, or we have to solve it. If we're going to solve it, we have to introduce natural logs to both sides. So we say the ln of e to the x equals the ln of 0. What do we do from there? Now we can use our power property. We can bring this x down in front. X ln of e equals ln of 0. Does anybody know what the ln of e is? Now we're at a point that you need to have things memorized, okay? The ln of e is 1, okay? The ln of 0 does not exist. Remember, what did we say on Monday about the domain for the natural log function? Anybody recall?
Is it everything but 0?
All positive numbers. Has to be positive. 0 is not positive. It's not negative either. So this does not exist. So what does that tell you? X times 1 does not exist. That means it never can happen. So e to the x equals 0? Never. So the only answer you get out of that is x equals negative 1. So there's a horizontal tangent line at x equals negative 1. Properties that you need to remember are e to the x. No, that's not. Properties that you're going to use enough to where it might be good to commit them to memory. ln of e is 1. ln of 0 does not exist. If you can just kind of memorize those two facts, you're going to be better off there. ln of e is 1 and ln of 0 does not exist. So we can do everything that we've been doing all year. Now we can just throw exponentials in there. Now, the most challenging thing for y'all with taking derivatives the rest of the way is forgetting things. A lot of times you're going to see this problem right here, and you're going to take the derivative of x and the derivative of e to the x and say the derivative is e to the x. Forget the product rule. So you've got to remember, you always, if you're multiplying, you have to use product. If it's dividing, you're probably going to have to use quotient. You've got to use your chain rule. You've got to use all of them. That's where students get confused here. The best way to overcome that confusion is by doing your homework and getting enough practice to it. So that's the reason we've had a few more problems to work this time around. Any questions, comments, observations? Okay. We don't have any more problems today. So you have the rest of the time where you can work on WebAssign, work on homework, work on FRQs. We are having a quiz on Friday. That's just like a daily grade, okay? So don't freak out over it, okay? Okay, you can take it some other time, Monday probably. All right, but we're taking a quiz on Friday. I'm just going to pull out 5, 6, 7 problems, just like what we've been working. Let you work them in class on paper and pencil. See what you can come up with on it, okay? Just another way for me to see that you're ready for the test. There are no more lectures between now and the test. So you've got a lot of work time between now and then. I'll stop talking. Go.